The scientific method. So today we're going to go over the scientific method again. The scientific method is what we think about. I have shown you now the scientific method song. Listen to it, enjoy it, get familiar with all of the steps. The scientific method is the step someone takes to investigate a question. They think about a hypothesis, they do an experiment, they test it, they write down their data, and they draw a conclusion, right? So we are trying to solve problems in the world around us. Scientists take time to think logically when they are investigating a question or a problem. They break things down in many different ways. So when we're thinking about science, we are thinking like a scientist, right? We ask questions. These are things that you do all day, every day, and you don't even realize it. When we ask questions, we can investigate them to find out the answer. The steps in the scientific method are: ask a question or identify a problem. Then you gather information and form a hypothesis. Remember, a hypothesis is a prediction of what's going to happen. Then you create your experiment to test your prediction. You collect data and observe all of the things that are happening. You then draw a conclusion. This happened because, and then you share your findings and you can retest what you do. When you ask a question, you investigate by saying things like, does exercise make your heart beat faster? Do plants need water to grow? Those are basic things you ask that you can 100% investigate. What questions could these children be investigating? Well, just like we talked about in our other slideshow, is how much water do plants need to grow? How tall will my plants grow if they're in sunlight? What are they predicting will happen? Well, maybe how tall their plants get. So, a hypothesis is a prediction. You can make a prediction, which is an educated guess, about how you think an experiment will turn out. I think that metal items will be the best conductors for electricity. I might say, I predict that plants grow better in water than in soda. We can make predictions based on what we kind of already know. So we think about things that we have, and when we think about plants in nature, we might say, well, it doesn't rain soda, so I don't think plants are going to need that to grow. But it does rain water, so plants probably grow well with water. So you can check and see if your hypothesis is correct. What are these two finely dressed children investigating? Well, one's dropping paper, one's dropping a bouncy ball. They might be investigating gravity. You might say, which object will fall faster? You might have said before, who can run faster? Well, what is their hypothesis? Well, they might be predicting and saying, I think a bouncy ball drops faster than paper. Yahoo! The way you move forward in this magical world of the scientific process is to design an experiment. If you want to test any of these things, you then have to actually go out and do an experiment to test them. So, when you are doing your experiment, is see, I will change one thing. So if those children are dropping objects, they might drop one bouncy ball and they might drop one piece of paper. So the height that they're dropping it has to be the same. How The fact that they're just letting it drop naturally without throwing it or any force has to be the same, but what can change is what they are dropping. So only one variable changes. How do I know it's a fair test? Well, a fair test is when you keep everything the same except the variable. So the one thing that you change is possibly, again, the object. If you're giving your plants water and soda, you're giving the exact same amount. You have your plants in the exact same spot, but the only thing you're changing is what liquid you are giving those plants, right? So you're only changing one thing. I will only change, if we're talking about that battery metal, they might say we only will change one thing in that experiment. So, what are these children investigating? Well, I'm not quite sure, but they could be looking at what's harder, wood. They might be looking at if that's marble, and they are going to check it. After you do your experiment, you want to make sure that you write everything down. You're writing down your materials you used, how high you were dropping maybe your bouncy balls from, and your paper, what changed, when you tested it. You want to give as much information so you can recreate it. So if you've ever done an experiment in your classroom, the teachers have to look at what other teachers have done and other scientists and make sure they have the right materials. They're making sure they have all of the variables the same so they can redo that experiment. When you do your experiment, you are then looking at the results. And after the experiment, you need to write down all those data so someone can then review it. What happened? What materials did you use? How did this work out for you? When you do that, you are drawing your conclusion. You're saying what happened in your experiment. Did one ball drop faster than the other? Did one plant grow better than another? Your hypothesis does not need to be correct. Sometimes there's also errors. For some wonky, odd reason, your plant and soda might just grow great, but then everyone else's didn't. So sometimes your hypothesis might be incorrect, and that is okay. So then you want to explain why your hypothesis was correct or not. You give your reasons and you explain what went right and what went wrong. Then you can do this experiment again and again and again. That's more scientists than in the classroom, but they do it so we can all see the results. And the reason we share our experiments is so other people in the world who live hundreds of miles away can do the same thing and learn about what we have done. So when we are doing the scientific method, we have those steps to follow and we make sure we do them so that everyone can continue to learn about the world around us.